All right, you guys just finished up something on vertical asymptotes. What we're going to do now is look at how to find horizontal and even, believe it or not, diagonal asymptotes. So just as a quick bit of review, here's a function. We've got f of x equals 3x minus 2 over x plus 4. And if I said, where are the vertical asymptotes, I'm going to be looking at the denominator. I'll look here and I'll say, where is that whole thing going to be 0? And it's kind of a no-brainer here, but when x is negative 4, the whole thing will equal 0. We'll be trying to divide by 0, and that's where our vertical asymptote is. We're going to start by looking at the graph of this thing. So I'll go over to the graphing calculator. I have to remember 3x minus 2 over x plus 4. And I'm going to put that in here to the y equals menu. A reminder that if you hit alpha and then F1, didn't work, let's try it again, alpha and then F1, there we go, I can create a fraction, numerator over denominator, and it was 3x plus 2 over x plus 4. And let's just double check that I got that right. 3x minus 2 over x plus 4, so let's make that quick change. There we go. And if I go ahead and graph this thing on the standard window, we can see there is our graph. And it certainly looks like we have that asymptote, the vertical one anyways, as predicted, right there at negative 4. Question is, though, there certainly appears to be a horizontal one, something around here-ish, that the graph is getting closer and closer to, both from the bottom and from the top. So how do we find that? Well, we can imagine that as we travel out this way, as our x values get very large, as they get bigger, here x is 1, then 2, then 3, then 4, etc. As x goes out further and gets to be a larger and larger value, the asymptote is getting closer and closer to our blue graph. So it stands to reason that if we looked at big values of x, we would probably find values that got closer and closer to our graph. What I'm going to do is I'm going to go to the table that's right above graph, second, and then table. And I'm going to look at what's happening to our graph as x gets big. Right now my x value is at 35, 36, 38, 45, etc. I can keep scrolling down, and my y value, or my blue graph, is getting closer and closer and closer to some number. Well, right now x is only 57. I would like x to be even bigger numbers. If I look above window, I see an option for table set. So right above window it says table set. So I'm going to say, let's go back to 0, but instead of going up by 1 unit at a time, let's go up by 100 units at a time. All right, so again, this menu appeared right above window. It said table set, and it said, where should we start the table? Please start the table at 0. Please make the table change, instead of by 1 unit, by 100. If I return to the table now, again, that's right above graph, I will see that my x values are going up by 100 every time. Now as I scroll down, I am going way out that positive x-axis. Now I'm at x equals 1500, 1600, etc. And if you look at the corresponding y values, our function is getting closer and closer and closer to 3. So that is, in fact, going to be our horizontal asymptote. Now, I could stand here at this smartboard for a long time, and I would still get values that were very close to 3, but will never actually be 3. We can double check that by going back to the y equals menu, and we can go down until I've got room here, and I am going to, oops, there it is. I'm going to put in the function y equals 3, and I will graph it, and I'll just check and see, does that look like our asymptote? And here it comes. And it certainly looks like, maybe if I zoom out a little bit, if I change my window, and I get a lot more x values, so maybe we'll go out to 100 for the x's, and I'll graph again. There's the graph. And let's see where that orange line comes in. And yes, it certainly looks like it's going to be our asymptote. So one method to find the asymptote is to put the function into the y equals menu. I've got it there in the blue. And then to go to the table and to scroll up or down for large values of x, or large negative values of x, until you get a number that seems to repeat. And in this case, it would be 3. So that's one method for finding asymptotes. Now, of course, you guys probably remember that these graphing calculators did not come along until very recently. And so there are methods to find it without using the graphing calculator. I'll talk about that right now. So I'm going to get rid of this. Why won't it erase? That's pretty funny. There we go. So we're going to get rid of that. All right. Now, we just found out that the asymptote and the graph get very close to each other when x is a really big number. All right. So let's make x a really big number. Okay. Let's just say, I don't know, x is 1,000,000. All right. X is a really big number. Now, a little bit of a thought experiment here. If I put 1,000,000 in here for x, all right, now my numerator is 3,000,000 take away 2. And I might ask you this question. If you had $3 million and I took away 2 of those dollars, is that going to make you very sad? The answer is probably not, because relatively speaking, $2 is very insignificant compared to 3 million. So you might say, okay, when the difference between 3 million and 3 million take away 2, no big deal. The top might as well just be that. For big values of x, the top is more or less going to be 3 million. 3 million take away 2, whatever. Same thing could be said for the bottom. On the denominator, if you have $1 million and I give you 4 more, sure, that's nice of me. But really, is that going to change your overall value very much? No. 4 compared to 1,000,000, not a big deal. So this part also is insignificant. So as we are talking about big values of x, 1,000,000, 1,000,000,000, 1,000,000,000,000, whatever you want to talk about, those little constants are really insignificant. So what this whole thing simplifies to is 3x over x. And of course the x's cancel, and guess what we get? 3. Where was that 3? It was our asymptote. Right there. The orange line was our asymptote. 3. So how do we do it without the calculator? Is to say, all right, I'm going to think about large values of x, 1,000,000. Or maybe you're going to say, just kidding, I'm going to call it 1,000,000,000. All right? As long as x is very large, then we can sort of do a thought experiment and figure out where the asymptote is that way. For the next couple of examples, I will do exactly that. Why was this thing stuck up here? Okay, go away. There we go. Now it's all gone. So we're going to put this one away. We're going to clear out this one. And we are instead going to grab a new function. All right. And again, I'm going to do this thought experiment in terms of x is a big number. All right. So x is, again, 1,000,000. All right. So if I look on the top and I have 1,000,000 squared, all right, in my numerator, 1,000,000 squared. Well, guess what 1,000,000 squared is? 1,000,000 squared is a 1 with 12 zeros. It's a trillion. What's a trillion plus 2 more? Again, the 2 is really insignificant. A trillion plus 2 might as well just be a trillion. On the bottom, in the denominator, I've got 4 trillion, take away 3 million. Again, relatively speaking, 3 million compared to 4 trillion is nothing. So all of this stuff is insignificant compared to this leading term. So what this simplifies to is x squared over 4x squared. Again, when we're talking about really big values of x. And this then simplifies to simply 1/4. So it may seem that our horizontal asymptote is 1/4. We can go back to the calculator, and I've worked my way ahead here, and I'm going to turn off that graph, and I'm going to clean up this. I will turn on this graph, and I will also go down to my orange asymptote graph, and instead of putting 3 in there, I'm going to put a 4th. And if we go to the graph, oh, and it looks like I'm going to have to change my window. Here we go, change my window. To go from -10 to +10, and my x or my y values don't have to be very much at all. Let's go from -2 to +2, and we'll now graph this thing. All right, so there is the graph, and here comes my asymptote, and yes, it certainly looks like that is the asymptote. All right, so again, I looked at big values of x, simplified the numerator and the denominator until I got just a value. Let's do this again. We will, here we go, erase all of this stuff. Go grab a new function. That one's going over there. Here comes this one. All right. And again, let's think about big values of x. Sure, let's make x 1,000,000. That's a long way out on the x-axis. So if I put 1,000,000, what's the difference between 1,000,000 in the numerator now? What's the difference between 1,000,000 and 1,000,000 take away 3? Not a big deal. All right, that 3 is pretty insignificant compared to 1,000,000. On the bottom, we've got 1,000,000 squared. That's again a trillion. So a trillion plus 2,000,000, not a big deal. A trillion is such a gigantic number that even changing it by 2,000,000 is not a big deal. So this insignificant. And so what this whole thing turns into is x over x squared, or 1 over x. Now again, let's think about this, because x is a gigantic number. All right? So this is más o menos 1 over 1,000,000 at this point. All right? Now, what is that number? What's 1 divided into 1,000,000 pieces? Or what's 1 chocolate bar chopped into 1,000,000 pieces? How big is each piece? Not very big at all. All right? This is 0.000001. It's really pretty much the same as 0. Okay? And now imagine as x gets bigger. What if x is a billion, a trillion, a quadrillion? That number is getting smaller and smaller and smaller. Eventually, it will be 0. If we go back to our calculator and we check it out, we'll go to the y equals menu. I'm going to turn off this one. I'm going to turn on the black function, which is that. And again, I got these preloaded in here. And we will get rid of that and put, let's put a 0. And if we graph it, here is the black function. And if we look at the asymptote following it in both directions very nicely. All right, I think we got two more actually. These ones are going to deal now with diagonal asymptotes. So let's get rid of all of this. And we'll do a couple that deal with diagonal asymptotes. So this dude going away. This one coming out. All right. Again, x is 1,000,000. So it's a big number. Of course, we can think of way bigger numbers than that, but let's start with 1,000,000,000. That means on the top I've got 2 trillion. This will again be 2 trillion because we're squaring 1,000,000. And then 2 trillion compared to 3,000,007, these are super insignificant. They don't really matter anymore. On the bottom, 1,000,000 take away 4. It might as well just be 1,000,000, insignificant in comparison. And so what we got now is 2x squared over x. This simplifies simply to 2x. Well, what's 2x? 2x you could think of as being this, where that's the slope, and there's the y-intercept. It's a line. And it's not a horizontal line anymore. It's, in fact, a diagonal line. A diagonal line that goes through the origin and has a slope of 2. If we go back to the graphing calculator, this will be interesting. We will find that you can actually have an asymptote that is horizontal. So we'll go down, and this time I believe we're talking about the purple function. Turn that one off, turn this one on, and we have to change our asymptote function to be now 2x. And if we draw a graph of it, there's our purple function, and maybe we have to change, we'll have to probably change our window again. Let's change our window to be, well, let's just do a normal window. And I think we are still not seeing the entire graph. So let's do some more y values. Maybe we'll go up to 30. And in the x direction, 20. Still no. So where did we go wrong here? Let's look at our y equals menu. Maybe I got my functions mixed up. No, it certainly looks like it should be there. So let's look down in the other direction, actually. Let's go negative 50 and negative 50. Negative 50. And now if we graph, here comes our purple function. And our orange function. And if you can imagine, as you look down here, as we go further and further down that way, the orange and purple graphs will get closer and closer and closer. And they will get really close, but they will never quite touch down there. Last graph. Let's get rid of all of this stuff. Again, x will be a million. So let's go down here. Pick our last graph up. There we go. And again, we're going to say, all right, what's going on with, if x is a super big number, now we've got x cubed. Forget about it. We have a quintillion. 3 quintillion. Take away 7,000,001, big deal. Totally insignificant. Down below, 9 trillion plus 3. The 3 is completely insignificant. This thing simplifies to, come on back, 3 x cubed over 9x squared. This simplifies to 1/3 x. Or if you want to think about it in terms of a line, 1/3 x plus 0. A slope of 1/3, a y-intercept of 0. We can return one more time to the calculator, go to our y equals menu, and as we go down here, turn that one off, turn that one on. Our asymptote now is 1/3 x. And we'll go back to a standard viewing window. Here comes our green function. Interesting looking function, and the asymptote going right through there. And yes, it appears to be the right mix. So, how do we find horizontal and or diagonal asymptotes? We are going to assume that x is a super big number. In that part of the graph, these other terms, these lesser terms, this one, this one, this one, they all become really insignificant. And so our graph might as well be simplified to that, which further simplifies until we get either a horizontal line or a diagonal line. With that in mind, go ahead and finish off the rest of this investigation.